Paul from Cyoda. In this video I'd like to quickly show you how you can query entities stored in Cyoda using SQL. Entities themselves are tree-like information structures which are not necessarily conducive to SQL, but in fact it does work quite well and quite easily. So I'd like to show you how that's done. In a previous session I showed you how we can define models and ingest data against those models. That's a key. And so once I have defined all kinds of entities in the system and ingest the data into it, how do I consume that with SQL? In the example here, basically there's just one entity type in the system, which is that Nobel Prize thing. I need to basically define my Nobel Prize model. I need to lock it so I can ingest data into it, and then I can post data to it. So now I'm sending this, saving that as an entity and all of its substructures containing hundreds of Nobel Prizes and thousands of winners. I can run it again. Now I've created another entity. It has its distinct ID, but the content, of course, is the same. I'll try it one more time. So now I've basically pumped the system up with information. And so how does that look from an SQL point of view in a relational database? If I look at this, actually there's nothing there yet because I need to create the schema for that. So the SQL interface into Cyoda provides you with virtual tables. They're not physical copies of anything, so they're views onto the entity structures of the system. So what we need to do is to create a schema. And you can get Cyoda to do that for you by just saying, here, look at all the models in the system and create schemas for them. So I'm going to ask it to do that, put a default schema into the schema called Paul. We run that. And so it's created it. You'll see those are the tables. I'll show it to you basically in the editor here. So if I look at my schema now I've got my Paul schema with 3 tables. And how do these 3 tables come to be? Let me try to explain that quickly. So here we have this tree-like structure, which you might already now feel a little bit familiar with, recognize those things. Graphically showing this as a structure where I split into subarrays of prizes with its attributes, and each prize has got laureates with its attributes. So what you have is one data element has got n prizes, and for each prize I've got n laureates. So one-to-n relations in a database is very easy. You don't need any relational tables. It's just a direct link of the parent to its parent ID and whatnot. And so this is how you can basically break down a tree-like structure into a relational one. And so in our given model, we've got sorry, wrong tool here. In our given model with 3 nested structures of arrays, I've got 3 tables. And now I can basically say, okay, here, let me flatten it again and say, give me all the first names and last names of the Nobel Prize winners, their category and their year. So I need to join these again by their parent IDs to the IDs. And because I ran duplicate information in separate entities each time, I shall have a look. I've got these guys 3 times. So I'll take one of them. They all contain the same information. Take that ID, go to my query, replace this and run it, and you can you've got basically the result here. So what you can do, build systems based on the entity paradigm with workflow processing and all that great event-based processing that we've got. You can then consume the data that is stored in the system, that is of course dynamically changing, but in a snapshot way. You can query the information in the system using SQL and therefore bridge it over to great things like feeding AI from data and integration with business intelligence and whatnot. So SQL is a very, very broadly used and massive coverage, and so you can talk to Cyoda also using SQL. Hope that was interesting, and thanks for listening. We'll see you next time. Bye.